the top of your notes, please write notes for Unit 5, Stoichiometry notes. So we saw that short video on Tuesday about kind of an overview of what stoichiometry is. But it uses, stoichiometry uses mole ratios to convert one substance to another substance in a chemical reaction. So far we can have some atoms of one substance. It could be an element or it could be a compound, and we could go from the atoms, we could find moles, and we could go from moles to grams, and we could all go in the other direction, different grams of something. We could find moles, and then you could find atoms or molecules. But that's all within one substance. The last piece we have to add to this whole unit really is how you can go from one substance to another in a chemical reaction. On Tuesday, you converted aluminum to copper. So we want to be able to predict how much copper should we be able to create from that amount of aluminum. So the coefficients in a balanced equation tell us the number of moles of each substance that reacts or is produced. So now we're going to go over to your foldable, and we're going to add one more thing. It explains how we use the coefficients to go from moles of one substance to moles of another substance. So, last Friday we added these three items to our foldable. 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. 1 mole equals the molar mass of any element or molecule in grams. And 1 mole of gas is equal to 22.4 liters of gas. Our fourth and final one is going to be moles of one substance equals moles of another substance. So how you can go from moles of one substance to moles of another substance. You are always going to need to use this fourth one when you have a target in a given. They're not talking about the same element or same compound. And the target and the given don't match types of substance. So we're just going to write an example. If we had 2H2 plus O2 yields 2 H2O, we have a balanced equation. 2 hydrogen molecules plus 1 oxygen molecule yields 2 water molecules. From this, we can look at our coefficients. It's 2, 1, and 2. We can convert from moles of hydrogen to moles of oxygen, or moles of water to moles of oxygen, or moles of hydrogen to moles of water. We can go in every direction. So we read these coefficients. We can write equalities. 1 mole H2 is equal to 2 moles, sorry, is equal to 1 mole of O2 is equal to 2 moles of H2O. So those would be all the equalities I can create from this balanced equation. 2, 2, 1, 1, 2, 2. It's okay if this is feeling a little weird right now. I'm going to practice using it in a second. So we'll start with an example. Let's say, what mass of water, H2O, is produced when 3 grams of H2 reacts with excess O2. What mass of water is produced when 3 grams of H2 reacts with excess O2? You always need a balanced equation, so I'm just going to rewrite it down here. 2H2 plus O2 yields 2H2O. And we're still going to use those same steps that we have this whole time, the same 5 steps to solve this. So step 1, find your target. What is it asking us to find? Yeah, mass of what specifically? Yeah, so we want grams of H2O. What are we given in the problem? What value is given to us in the problem? 3 grams of what? 3 grams of H2. So now we have to start being specific about what substance we're talking about. Since my target is H2O, my given is H2, those don't match. Since these are not the same substance, we're going to have to use a mole ratio to jump from moles of hydrogen over to moles of water. So whatever these don't match, you're going to need to use the mole ratios. So we're going to compare hydrogen to water. So sometimes I put a star over them, or I put a square on them, so I just focus on my 2 substances. And then let's look at their coefficients. We can say 2 moles of hydrogen is equal to 2 moles of H2O. You could simplify that to 1 and 1, but we'll just leave it for now. So we have to get everything to moles. Moles is our bridge between 2 different substances. So now we know we have to get our given hydrogen to moles. We'll have to get our moles of water back to grams to get to our target. So looking on your foldable, which one of these, 1, 2, 3, or 4, which one compares mole to mass? Moles to grams. Second one. We're going to need 1 mole of H2 is equal to the molar mass of H2. And 1 mole of H2O is equal to the molar mass of H2O. So when we find our molar masses, H2 would be 2 times 1.0, which equals 2.0 grams. To find our molar mass of water, we've got HO, 2 H's, 1 O. Two plus 16 is equal to 18 grams. So these are our 3 equalities we have now. 2 moles of H2 equals 2 moles of H2O. 1 mole of H2 is equal to 2 grams. 1 mole of H2O is equal to 18 grams. So we'll use those three qualities to get all the way from our target to our given. From our given to our target. Step 3, set it up. So, always start with your given in the first box, which is this one, 3 grams of H2. And then I'm going to choose whichever one of my three qualities has grams of H2 in it. Which one has grams of H2? The second one. So 2 grams of H2 to 1 mole of H2. Now that I'm in moles, I can jump from moles of my given to moles of my target. Using which one? Which one compares moles of hydrogen to moles of H2O? The first one. So we know 2 moles of H2 are equal to 2 moles of water from our coefficients. Now that I'm in moles of water, I wanted grams of water, so I'll use my last one. 1 mole of H2O is equal to 18 grams of H2O. That's my setup. Start with my given, canceling units until I get to my target units, grams of water. Step 4, check that your units cancel. Grams, grams, moles, H2 moles, H2 moles, H2O, moles of H2O. To solve it, multiply across, divide down, try it with me. 3 times 1 divided by 2 times 2 divided by 2 times 18 divided by 1. What do you guys get? Huh? Yeah, you should get 27.0 grams of H2O. It was a long problem, huh? That's bringing together every single thing we've worked on in this unit. Having a balanced equation, using your inequalities to go from one unit to another and setting up the problem. The only thing new today is this one, stepping from one substance to another. So using the mole ratios or the coefficients. Using the mole ratios, the coefficients from the balanced equation, whenever your target substance and your given substance don't match. So we're going to try another one right now. How are you guys feeling? A little shaky on that? Yeah. We'll try this next one, and this next one I'll let you guys do more of it on your own, and I'll just walk around and help. Okay?